Hello guys, this video is the first of two videos covering the topic of pH scale. In this video, I'm going to explain what is pH, the self-ionization of water, the ion product constant of water, the difference in the hydrogen ion concentration in acid, basic, and neutral solutions, and finally do some exercises. So first, as I mentioned in the previous class, pH means hydrogen potential, and this is because it's related with the hydrogen ion concentration. And if you remember from the previous classes, it goes from 0 to 14, from the most acidic to the most alkaline substances, and in the middle we have water. And that's important because we will start with the self-ionization of water, a topic that we have already covered in the previous class. And it is just how the water can ionize itself and produce hydronium ions and hydroxide ions. So one water molecule acts as an acid, the other one as a base. The acid is losing one hydrogen ion and produces a conjugate base. The base is gaining one hydrogen ion and a positive charge, and it produces a conjugate acid. In this case, for pH, we will consider the concentration of hydronium ions equal to the concentration of hydrogen ions. The brackets mean the molarity, the concentration which is given in molarity. Brackets are concentration in molarity. And remember, molarity is equal to moles divided by liters of solution. So again, water can self-ionize in water and it will produce hydrogen and hydronium and hydroxide ions. These two will be considered as equal. Why? Because this is water, H2O, and another hydrogen together. That's why we have H3 plus. So for pH again, we will consider hydronium ion and hydrogen ions concentration as equal. When we have pure water, that pure water is in this process of self-ionization. But these ions are present in a very, very low amount, 0.00000001 molar. That's a very, very small amount, and the same amount for hydroxide ions. And these numbers are equal to 1 times 10 to the minus 7 in both cases. And that's important because that's the water concentration, the hydronium or hydrogen ion concentration and the hydroxide ion concentration. And this number may be familiar because water is neutral and it has a pH of 7. But this is a part that we will cover in the next topic. So we have something called the ion product constant of water, and it's a value of the equilibrium in this self-ionization process of water. This ion product constant of water, it's abbreviated as Kw. And it says that the hydronium ions or hydrogen ions equals the concentration of hydroxide ions. This is that they are in the same concentration, 1 times 10 to the minus 7 for hydrogen ions, 1 times 10 to the minus 7 for hydroxide ions. And if we multiply those two numbers, we get the ion product constant of water, that it's equal to 1.0 times 10 to the minus 14. And it is a constant, so it will remain always the same. So I recommend you to write this formula and this value. You will use it by the end of this video in the different exercises that we will do. So again, the ion product constant of water, Kw for short, it's equal to the concentration of hydrogen ions multiplying the concentration of hydroxide ions. In pure water, they have the same concentration, so it's just a multiplication of 1.0 times 10 to the minus 7 times 1.0 times 10 to the minus 7. If you remember the rules of exponents, if you multiply the numbers, the exponents just add, and they are minus 14. In an acidic solution, the hydrogen ion concentration is greater than 1.0 times 10 to the minus 7. Remember, this number is 0.0000001 molar. Oh, sorry, 1 molar. So if the number is greater than that, it will be an acidic solution. If it's less than that, sorry, if it's equal to that number, if the hydrogen ion concentration is equal to 1.0 times 10 to the minus 7, it will be a neutral solution. And finally, if that number, the hydrogen ion concentration, is lower than 1.0 times 10 to the minus 7, it will be a basic solution. If it's greater, acidic solution. If it's equal, neutral solution. And if it's lower, it will be a basic solution. Here we haven't reached the part of the pH scale. That's for the next topic. Here we are just focused on the hydrogen ion concentration. And one important thing that you have to notice is that if you increase the hydrogen ion concentration, the hydroxide ion will decrease if that's an acidic solution, and a solution which has more hydrogen ion concentration. If it's a neutral solution, those two ions are in equilibrium. And if it's a basic solution, the hydrogen ion concentration is less than 1.0 times 10 to the minus 7. That's what I just say in the previous slide. And also, if this one decreases, if the hydrogen ion or hydronium ion concentration decreases, the hydroxide ion concentration will increase. And that makes sense because hydroxide ions are for bases, and this will be a basic solution because it has more hydroxide ions. So let's do the exercises. It says calculate the hydrogen ion concentration and the hydroxide ion concentration using the ion product constant of water, Kw. Calculate those concentrations using Kw. And the exercise says at 298 Kelvin, which is around 25 degrees Celsius, the hydrogen ion concentration in a cup of coffee is 1.0 times 10 to the minus 5 molar. And they ask, what is the hydroxide ion concentration in the coffee? And finally, is the coffee acidic, basic, or neutral? So let's see. We know that the value of Kw is 1.0 times 10 to the minus 14. So that's a known variable. It's a constant. It always will be the same value. And we have the hydrogen ion concentration. And they are asking for the hydroxide ion concentration. Let's forget about this for a moment because this is for water. And here we are dealing with coffee. So we have two known values, Kw, 1 times 10 to the minus 14, and the hydrogen ion concentration, which is 1 times 10 to the minus 5. And they are asking about the hydroxide ion concentration. We have the formula that says that water constant equal to the hydrogen ion multiplying the hydroxide ion. Can we calculate this if we have this and this? Yes, it's a simple multiplication, so it will go to the other side as What type of operation? Yes, as a division. Kw divided by hydrogen ion concentration will be equal to the hydroxide ion concentration. And that will be equal to 1.0 times 10 to the minus 14 divided by 1.0 times 10 to the minus 5. I recommend you to do this in your calculator because those numbers usually will be different than 1. In this case, it's quite easy. It's just 1 times 10 to the minus 14 divided by 1 times 10 to the minus 5. And the answer? 1 times 10 to the minus 9. Again, you can easily do that by subtracting these numbers and getting the exponent. But once again, I recommend you to do this in your calculator to practice for the next exercises. So this is the answer. It is the hydroxide ion concentration in the coffee. And additionally, they are asking, is the coffee an acid, a neutral, or a basic solution? Well, we have that this is the hydrogen ion concentration, 0.00001 molar. And we said if a number, if the hydrogen ion concentration is greater than this number, it will be an acidic solution. So is this one greater than 0.00001 molar? Yes, it is greater. It has less zeros. So it's an acidic solution. Coffee. And that will be the answer to the second question. Let's practice this. We have this exercise, and I'm going to finish doing the first two. Yes. It says calculate the hydroxide ion concentration of each aqueous solutions with the following hydroxide ion concentration. Remember, hydroxide ion it's a synonym of hydrogen ion concentration. So we have these values. And again, omit this because it's for water. Just focus in this and this. And again, we have the value of the constant of water, the ion product constant of water, Kw. And for the exercise one, for the exercise with the letter A, we know that the hydrogen ion concentration is 1 times 10 to the minus 8. So again, we will use the formula and solve for the hydroxide ions. So it will be hydroxide ions equal to the water constant divided by the hydrogen ion concentration. 1 times 10 to the minus 4, 1.0 times 10 to the minus 14 divided by 1.0 times 10 to the minus 8. Again, I recommend you to do this in your calculator to practice, and the answer will be 1 times 10 to the minus 6. That is the hydroxide ion concentration. Now let's do the letter B. Let's check the number 1. Yes, it is correct. And it's a basic solution. Now let's do the why is a basic solution? Because this number is less than 1 times 10 to the minus 7. But again, they are not asking about that. Don't worry. In the letter B, it's exactly the same. We have the value of the hydrogen ion concentration and the hydroxide ion concentration. So we can use the same formula that says that this number will be equal to Kw 1.0 times 10 to the minus 14 divided by the hydrogen ion concentration for the second one, 4.2 times 10 to the minus 8. In that one, you need to use your calculator, and the answer will be 2.38 times 10 to the minus 7. And that's the answer. And I will let you do the other two for homework, and I will finish the video here. So thank you, and please check the next video.